Hello everyone. In the beginning of the class, let us see new announcements. Okay, the first new announcement is May 12th, 2022 class videos uploaded. Hello everyone, I have uploaded class videos of May 12th, 2022 to YouTube. Their URLs are this, and this. Best regards, Wei Zhen. Okay, the second new announcement is the handout of Chapter 2 has been updated, version 2022-0516. Hello everyone, I have uploaded the latest version of the handout of Chapter 2 to eCourse2 website. The location and the file name are eCourse2 website, wireless communications and machine learning. Course content, handouts, Chapter 2 handout 2022-0516.pdf. Best regards, Wei Zhen. Okay, next let us look at the progress of the last class. Okay, in the last class we have taught to Chapter 2 handout, page 47, problem 47, solution, equation 3, line 6. Okay, let us open the Microsoft Word file. Okay, so we are derive the second equality of equation 45 in the handout. Okay, let us go to equation 55, not 54, not 45. Okay, so we are deriving this equality now. Okay, so first we can find that the second line of the equation 54 can be split into these four terms. Okay, and obvious the first term is equal to a zero vector. Okay, and we are processing the second term in equation 1. Okay, that is this term. Okay, so after some computation we find that this term is equal to partial over partial beta. Summation j is equal to 1 to m. Summation I is equal to 1 to n. yi xij beta j. Okay, so we can see that this is a scalar, and now we want to find its partial derivative to a vector beta. Okay, so how to compute the partial derivative of a scalar to a vector? Okay, this is about the topic matrix calculus. Okay, let us see. Okay, a scalar by vector. Okay, the derivative of a scalar y by a vector x, which is equal to x1, x2 to xn transpose, is written in numerator layout notation as partial y over partial x is equal to a vector. Okay, the first element is partial y over partial x1, and the second element is partial y over partial x2, and so on. And the last element is partial y over partial xn. Okay, so let's go back to the Microsoft Word. Okay, so we know that this is equal to a vector. Okay, so let insert. Okay, this. Okay, so first term is a partial derivative, okay, which is a fraction, and the numerator of the fraction is equal to partial, and this term, okay, and over partial and beta 1, okay, like this, okay, and so on. Okay, we place dots here, okay. Then the final term, the final element of this vector is okay, it's also a fraction, okay, and the numerator is the same as the first element, and the denominator is partial beta m, okay, because there are totally m elements in the vector beta, okay. However, we need to add a transpose here. Okay, why do we need to add a transpose here? Okay, also in the Wikipedia, it do not have a transpose, okay, on this vector. Okay, however, if we do not add this transpose, the result will be wrong. Okay, if we add the transpose, the result is correct. Okay, so Wikipedia is not always correct. Okay, you must check the correctness by yourself. Okay, so okay, next. Okay, it is equal to, okay, a vector again. Okay, a bracket. Okay, and 3 boxes. Okay, so the first term, okay, we can find the term that contains beta 1. Okay, for the term that does not contain beta 1 is to be treated as constants, and we can cancel them. Okay, so the term that has beta 1 is when j is equal to 1. Okay, so this is summation I is equal to 1 to n yi xij, xi1 beta 1. Okay, and take take the partial derivative with respect to beta 1, we have this equation. Okay, so it is equal to this equation. Oh, sorry. Okay, it is equal to. Oh, sorry. We have do not have a fraction here. Okay, so first term is summation I is equal to 1 to n yi xi1 and dots. Okay, and the final the last element is equal to, okay, we need to also to find the term in the numerator that contains beta m. So when j is equal to m, okay, this is equal to summation I is equal to 1 to n yi xin. Okay, so all we need to do is to copy the first element and change the index 1 to m. Okay, it is very convenient. Okay, and take the transpose. Okay, and let me align at the equality. Okay, good. Okay, so this is equal to, okay, let us input a parenthesis and transpose. Oh, sorry. Transpose. Okay. Okay, so this vector can be separate or can be written as the product of a vector and a matrix. Okay, so first let us see the vector. Okay, so it is equal to, we can see that summation I is equal to 1 to n yi, okay, xi1. Okay, so this vector, okay, times a matrix. Okay, oh, sorry, here. Okay, so the first element of the vector should be yi, and I is equal to 1. So it should be y1. Okay, and dots. And the last element of the vector is yi, I is equal to n. Okay, so we only need to copy y1 here and change the index to n. Okay, like this. Okay, then we can see that y1 to yn, according to the rule of multiplication between a vector and a matrix, we should take this row vector and times this column vector, and then we will obtain this element. Okay, so the first element here, okay, should be xi1, where I is equal to 1. Okay, so we copy this, okay, xi1, okay, here, and change I to 1. Okay, okay, and so on. Okay, vertical dots. Okay, and the last element should be xi1, and I is equal to n. Okay, so this should be n here. Okay, and so on. So we input dots here and a diagonal dots here and a horizontal dots here. Okay, and finally we can see that xi1 is changed to xin. Okay, so all we need to do is to copy x11 here and change the second index to m. Okay. Okay. So similarly, for this element, we can fill the vertical dots, and for the last element of the last column, we can only copy xn1 to here and change the second index to m. Oh, sorry. Okay, like this. Okay, so let me align at the equality. Okay, good. Okay, so next it is equal to, okay, it is equal to parenthesis and transpose. Oh, sorry, transpose. Okay, and the first vector is equal to y transpose. Okay, it is equal to y. okay, bold and not italic transpose. And the second matrix, okay, we can see, compare it to, okay, it matrix, they are the same. So this matrix is equal to X. Okay, so we can directly copy X here and paste here. Okay, so let me align it at the equality. Okay, so next it is equal to, we can see that Y transpose times X and transpose again, so which is equal to X transpose times Y. Okay, so X and transpose times Y, and Y is bold and not italic. Okay, and we call this equation 3. Excuse me. Okay, the third step is to consider the third term in 1. Okay, let us go back to equation 1. The third term in 1 is partial beta transpose X transpose Y partial beta. Okay, so we can copy this. Okay, because this term, beta transpose X transpose Y is, not bold, is a scalar. Okay, so why does it term equal to, why is this term equal to a scalar? Okay, because let us see, beta is an m by 1 vector, so beta transpose is an 1 by m vector, and X is an n by m matrix, so X transpose is an m by n matrix, and Y is an n by 1 vector. Okay, so beta transpose is 1 by m, and X transpose is m by n, and Y is n by 1. So after multiplying them together, it is its dimension is 1 by 1, which is the scalar. Okay, so let us see the set. We need to copy the third term in equation 1. Okay, and paste here. Okay, so it is equal to, let us insert a fraction and a partial. Okay, because beta transpose X transpose Y is a scalar, so it is equal to the transpose of itself. Okay, so let me insert a parenthesis and copy this, paste. Okay, and it is the transpose, and over partial beta. Okay, and so this is equal to, a fraction and partial. Okay, and beta transpose X transpose Y, and all take the transpose is equal to Y. okay, transpose, and x transpose and transpose again, which is equal to x. Okay, and finally beta transpose and transpose again, which is equal to beta. Okay, so we can see that partial y transpose x beta partial beta, okay, it is equal to not here. Okay, above A. Okay. Oh, good. Okay, it is we call this equality A, and it is equal to this term, okay, x transpose y. Okay, so why does this is equal to x transpose y? Okay, first let us call this equation 4. Okay, where equality A holds because of equation 3. Okay, because a partial y transpose x beta over partial beta, okay, is equal to the second term in equation 1. So it is equal to this x transpose y, okay, because of equation 3. Okay, and the fourth step, consider the first term in equation 1. Okay, so let us first copy. Okay, copy this term and okay, paste here. Okay, so beta transpose x beta, which is equal to parenthesis, okay, and okay, x and beta, okay, and transpose, okay, like this, and times x beta. Okay, so next it is equal to we know that the transpose a vector times the times another vector is equal to the inner product, okay, of these two vectors. Okay, however, you should note that these two vectors should be real vectors. Okay, if there are complex vectors, the transpose must be replaced by Hermitian. Okay, so it is equal to the okay, this, okay, angle, left angle and right angle, and x beta, okay, and x beta again. Okay, align at the equality. Oh, good. Okay, so a vector take inner product on itself. It is equal to the Euclidean norm. Okay, this one. Okay, it is equal to the square of the Euclidean norm of itself. Okay, a line at the equality. Okay, we call this equation 5. Okay, where okay, it is 25 minutes. Let us take a break.